What mode is covered, for example, rail, truck, ship, and how far of the journey is covered by Transporeon and Roambee, telematics aggregation and sensor-driven?
With sensor-driven visibility, it's covered every single mode of transport, to include the ones that you listed, because we're tracking at the shipment level or the asset level. So wherever you can embed a device and get connectivity is where you can get visibility for the movement of those goods. It in some cases depends. If you're in a rail car that's enclosed that has metal all around it, you may not get GPS device. So we have customers that we work with where we have the devices on the outside of the rail car. But generally speaking, you can get connectivity across all modes of transport because you have the embedded device. So anywhere you can get connectivity, which is just about everywhere, you can get visibility with sensor-driven visibility.
Yeah, and for this telematic visibility, this modes is a complicated story. With a road, it's relatively straightforward when we have a carrier and carrier telematic connection, and we know the truck license plate number. And if it is a simple transport, full truckload from loading to unloading, and nothing happens in between, then we have easily 100% coverage. Now, if there is anything happening, a change of trucks or several transports combined in single truck, like LTL use case parcels, then it becomes more and more complicated. And mostly the complication comes from the additional info what we need from the carrier. So we need to know when the truck was actually shipment was moved to another truck or to another mode. And with other modes, it becomes even more complicated because we need several different parties to get this data. In principle, it is possible to cover all these modes. So we have very good coverage for truck in many countries. For rail, we have first projects with some rail providers also to get rail car locations and have tracking with DB Rail, for example, Deutsche Bahn. For ocean, also, we are just starting with some projects where we get this data for carriers and from ship owners and from AIS, which is kind of a global tracking system for ships. So we do get pieces of data here and there, but especially for the other modes than road, also air actually is this kind of additional one, what we are adding to the system. But for other modes, the thing is really to get information from the carrier, some kind of milestones or extra status updates. So we need to know what is happening. So much more focus is not on the location where it is right now, but where it is in the supply chain. So is it already loaded? Is it waiting for loading to the new place? For air, for example, the actual shipment location is relatively short. It's a couple of hours of flying, and the total shipment time can still be days because there are long waiting times in any place of this journey. So the multimodal telematics tracking is not really telematics tracking. It is about connecting to the different systems and to get this helping information that what is really happening. And yeah, we do have some elements of telematics, but it is complicated. There are some cases maybe where it works even better than with sensors. For example, for transocean container transports, where the network connectivity is really completely missing from the ship because of the container itself is a challenging. Plus, if it's on high seas, then there is no satellite communication. It's too expensive. And their only way is to use this AIS tracking system, which is working with a satellite also, but it assumes that we know exactly the ship where it is loaded. And this getting to know this ship is already a difficult part, and we need to get extra information and connection to the carrier to get this in one hand. And in the other hand, a lot of this long sea trackings in real time, the focus is still on the port. So what is happening around the port? When ship has already sailed and is somewhere in the middle of Atlantic Ocean, the real-time location value is quite marginal, actually. It kind of confirms that the ship is still there and has not sunken, but important part is really when it's going near to the next port, and this is where actually sensors can already take over and have a coverage. So they are quite different, I would say. It's not clear winner or even clear formula which one to use. Actually, probably in the future we will see combination of sensors and telematic for this kind of complex multimodal scenarios.